What if I told you there's a machine floating 1,000,000 miles from Earth that lets us see the birth of the very first stars? Not just stars, galaxies, worlds, light that's been traveling for over 13 billion years just to reach us. Now, what if I told you this machine was never supposed to make it? That the idea was too ambitious, the design too fragile, the cost too high, and the odds near zero. For more than 2 decades, scientists, engineers, and dreamers fought to bring it to life. And for most of that time, it looked like they might fail. Delays, overruns, critics, political attacks, cut funding. Even within NASA, there were moments they thought about pulling the plug, because what they were building wasn't just complicated, it was borderline insane. A telescope with a mirror too big to launch, so it had to fold like origami. A machine so delicate, even a single tear in its sunshield could doom the mission. A spacecraft with no backup plan, no repairs, no second chances. Once it launched, there was no turning back. But here's the miracle. It worked. Against all odds, against gravity, against time itself. The James Webb Space Telescope didn't just survive. It became the most powerful eye humanity has ever turned toward the cosmos. It's seen the unseeable, measured the invisible, and revealed secrets that were sealed away since the dawn of time. But this story isn't just about space. It's about us, about what we dare to build, about what it means to look up and refuse to settle for what we can see. This is everything we know about the telescope that shouldn't exist. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. It started with awe, and then frustration. In 1995, the Hubble Space Telescope captured what would become one of the most iconic images in astronomy, the Hubble Deep Field, a tiny dark patch of sky no wider than a grain of sand held at arm's length. And yet, within that nothingness, Hubble revealed thousands of ancient galaxies, frozen snapshots of the early universe shining faintly through the darkness. It was beautiful. It was humbling. And it raised a terrifying question. How much were we still missing? Because even Hubble, powerful as it was, had its limits. It couldn't see far enough. It couldn't see deep enough. It couldn't pierce the veil of cosmic dust or catch the ancient infrared light from the very first stars. Astronomers knew if we wanted to see the true beginning, we needed to build something new, something beyond Hubble, something almost impossible. They dreamed of a telescope that wouldn't just orbit Earth, but escape its shadow completely. One that wouldn't just look into the visible universe, but into the invisible one. One that could capture the moment galaxies were being born, when the universe was still in its infancy. But dreams like that come at a cost. In this case, billions of dollars, 2 decades of research, and a blueprint that pushed every boundary of science and engineering. The telescope had no name yet, no budget, no political support. All it had was a question. What if we could actually do it? What if we could build the first true time machine, one that looked not just out into space, but back into the very fabric of time itself? And thus, in the shadow of Hubble, the dream of James Webb was born. A mirror too wide to launch, a sunshield too thin to touch, a telescope too complex to fail, but too far away to ever fix. That was the blueprint. If you're wondering why they didn't just upgrade Hubble, they tried. And they realized Hubble wasn't just limited. It was limiting. To go deeper into the cosmos, we couldn't build a better Hubble. We had to build something completely different. something designed not for Earth orbit, but for deep space, 1 million miles away, at a gravitational balancing point called L2. It had to be cold, colder than Pluto, colder than anything we've ever sent that far, because infrared light, the ancient glow of the early universe, is drowned out by heat, which meant the telescope would need to shield itself from the sun, the Earth, even the moon, forever. So they designed a sunshield the size of a tennis court, made of 5 layers of Captain thinner than a human hair. They created a gold-plated mirror 21 feet across, built from 18 hexagonal segments that had to unfold like a puzzle in space. And then they added the real twist. There would be no second chances, no shuttles to fly out and fix it, no robots to lend a hand, no margin for error. Everything, the mirrors, the shield, the instruments, the folding, the alignment, had to work perfectly the first time. And if just one component failed, the entire mission would be lost. They called it 300 single points of failure. Others called it madness. Even within NASA, there were moments when people looked at the plans and thought, we're building something that can't be tested as a whole and sending it to where no one can ever reach it again. Are we sure this is a good idea? But no one had ever reached back to the beginning of time before, and the universe doesn't reveal its secrets easily. So they pushed forward. They built the unbuildable, engineered the impossible, and launched one of the greatest technological gambles in human history. By 2011, the James Webb Space Telescope was no longer a dream. It was a disaster. The project was years behind schedule, billions over budget, and the public, who once saw it as a beacon of human achievement, now saw a black hole for money. The U.S. House of Representatives introduced a proposal: cancel it, shut it down, end it, before it could fail even more spectacularly. The headline was brutal: NASA's $8 billion mistake. For the scientists who had poured decades into the mission, it was devastating. They had sacrificed careers, relationships, even their health. They had taken the biggest swing in the history of space science. And now it looked like the world was turning away. And maybe, rightfully so. Even within NASA, some questioned if it was time to cut their losses. We're building a telescope we can't test, one with over 300 points of failure. What happens if it doesn't work? What if it launches and goes silent forever? The dream was collapsing under its own weight. Every delay, every design change, every dollar spent became another reason to kill it. But then, something happened. Not a miracle, a movement. Scientists, educators, astronomers, even students began to speak out. They wrote letters, held rallies, flooded congressional inboxes. They reminded the world this wasn't just another NASA project. This was our generation's Apollo, a mirror pointed at the beginning of time, a chance to answer questions older than civilization itself. And in July 2011, after tense debates and intense public pressure, Congress voted. James Webb would survive, but barely. The budget was locked, the deadline was final, and the pressure was cosmic. There would be no more lifelines. From this point forward, any mistake could be fatal. The dream wasn't dead, but it was walking on a razor's edge. December 25th, 2021. While much of the world unwrapped gifts under Christmas trees, NASA unwrapped a different kind of miracle, a machine, a hope, and a $10 billion risk. At precisely 7:20 a.m. EST, the Ariane 5 rocket ignited over the Guiana Space Center in French Guiana, carrying not just a telescope, but an entire era of science on its back. There were no guarantees, no fallback plans. Just one shot to send the most complex space observatory ever built on a month-long journey to a destination 1,000,000 miles from Earth. Millions watched in real time. Some prayed, some cried, some couldn't look at all. Because we all knew if anything went wrong, even the tiniest glitch, the telescope would drift off into deep space, dead on arrival. But then, something beautiful happened. Stage separation, perfect, trajectory, flawless. Solar panel deployment, successful. Cheers erupted across NASA, ESA, and CSA mission control. But no one was celebrating too soon, because the launch was just the beginning. What followed was a month of terror, known inside NASA as the 30 days of anxiety. The telescope had to unfold itself in space, like a blooming flower, petal by petal, step by step. Over 300 critical mechanisms, each with the power to ruin the mission. Mirror segments had to lock into place with nanometer precision. The sunshield, 5 fragile sheets of Captain, had to stretch out perfectly, without tearing. Every moment felt like a coin toss, and all NASA could do was wait. But the miracle continued. One by one, the deployment succeeded. The origami unfolded. The telescope lived. And on January 24th, 2022, after 29 days of drift, burn, and fear, Webb arrived at its final destination, L2, the second Lagrange point, a place of balance, of silence, of clarity. And there, it opened its eyes for the very first time. It didn't arrive with a bang or a blinding flash. It came quietly, softly, like the gentle breath of a cosmos we'd never truly seen before. On July 12, 2022, NASA released the first full-color images captured by the James Webb Space Telescope, and the world stopped. What we saw was not just beautiful, it was overwhelming, almost unbelievable. A field of galaxies so dense, so deep, that every dot of light, every shimmer, was not a star, but a galaxy. Some of them distorted into curves by gravitational lensing, bent by the invisible hands of dark matter. We weren't just looking at space, we were looking back in time, 13.1 billion years back, to see stars being born in nebulae, to watch planets forming in dusty disks, to witness the light of ancient suns that burned before Earth ever existed. It felt like magic, but it was science, built by hands, driven by curiosity, powered by a will to see further than we've ever seen. Even the most skeptical scientists, the ones who had worried for years, had to admit, it worked, and it's better than we ever imagined. In a single moment, James Webb delivered more than just images. It delivered clarity, perspective, and proof. Proof that we are not just wanderers. We are observers. We are builders. We are stargazers with tools sharper than ever before. And we had just begun. The first images were only the beginning. What followed was a cascade, a flood of revelations. Webb peered into the Carina Nebula, a stellar nursery teeming with young stars, some just being born, others dying. It revealed cosmic cliffs, towering clouds of gas and dust. So massive, they looked like mountain ranges made of fire. But that wasn't all. Webb also stared into the Southern Ring Nebula, a dying star shedding its final layers. For the first time, we could see not just the outer shell, but the binary companion star hidden at its heart. Astronomers had theorized it for decades, but Webb showed it. Clearly, plainly, undeniably. And then came WASP 96b, a planet outside our solar system, an exoplanet, and not just a blurry blob on a graph, but a real atmosphere, one we could analyze. Webb detected water vapor in the atmosphere of a world 150 light-years away. Let that sink in. We're not just finding new worlds anymore. We're studying their skies, reading their weather, hunting for life, molecule by molecule. That's the power of Webb. It doesn't just take pretty pictures. It rewrites what we thought we knew. We're seeing the universe as it truly is, not filtered through what our eyes can handle, but through the lens of pure physics and light older than time. Every new data set, every observation feels like a gift, and yet, it's only the start. James Webb was built to last a decade, maybe more. And every day it's out there, it's showing us a cosmos more dynamic, more chaotic, more alive than anyone imagined. Since its first images were released, James Webb hasn't just amazed scientists, it's broken them in the best way possible. Every image, every data set, every silent whisper from deep space is a reminder. The universe is not what we thought. It's bigger, it's faster, and it's way weirder. Let's talk about one of the first shocks, WASP 96b, a gas giant over 1,000 light-years away. It was one of the first exoplanets Webb pointed at, not just to take a picture, but to look through its atmosphere. And what did it see? Water vapor, on a planet with no surface, no oceans, but swirling clouds of hot gas, a complete water signature, in infrared, clear as day. It proved that Webb could read alien skies, and that we're now in the age of exoplanet forensics. Then there's TRAPPIST-1, a star system with 7 Earth-sized planets, orbiting a cool red dwarf just 40 light-years away. Several of these worlds orbit in the habitable zone, where temperatures might allow liquid water. And now, Webb is scanning their atmospheres to look for methane, ozone, carbon dioxide, even dimethyl sulfide, a molecule that, on Earth, is produced only by life. Imagine that. We're not talking about finding life someday. We're testing for it now. But it gets wilder. In late 2023, Webb detected organic molecules, carbon chains, in a galaxy 12 billion light-years away. These aren't just random chemicals. They're the kind of molecules that lead to amino acids, that lead to proteins, that, in the right environment, could lead to life. The further Webb looks, the more it finds ingredients for biology scattered across the universe. Not rare, not unique, but common. And then came the black holes. Astronomers expected to see tiny seed black holes in the early universe. Instead, Webb found fully grown monsters, 1 billion solar masses, already formed less than 1 billion years after the Big Bang. That's impossible. Or at least, it was. Now? We don't know. Every answer Webb gives opens 3 new mysteries. Even in our own solar system, Webb is turning heads. It captured weather systems on Titan, a moon with lakes of methane and ethane. It spotted auroras dancing across Jupiter's poles, and it's watching the dust belts of Uranus and Neptune, revealing hidden dynamics we've never observed before. The telescope isn't just looking out, it's looking back, down, and in between. And that's the magic. James Webb isn't just a space telescope, it's a mirror, showing us not only the universe's past, but the future of discovery, the future of ourselves. We built a machine that could peer into creation itself, and what it's telling us, again and again, is that the universe is not cold. not silent, not empty. It's alive, it's loud, and it's calling us forward. In the silence beyond Earth, 1.5 million kilometers away, a golden mirror hangs motionless in the cold black sea of space. It doesn't move, it doesn't speak, but it sees everything. That is the legacy of James Webb. Not just in the data it sends, not in the images we frame on walls, but in the shift it caused inside all of us. Because every discovery it makes forces us to ask deeper questions. Who are we in all of this? How did we get here? Are we alone? And even if we never find life out there, even if Webb never sees a single alien microbe, it will still have done something profound. It brought us together, to build, to hope, to wonder. It showed us that science is not cold, it's human. It's messy, emotional, frustrating, and utterly beautiful. You can feel it in the voice of the engineers when that first image came down, in the tears of scientists watching distant galaxies unfold, in the silence of viewers like us just staring at the screen, mouths open, eyes full, because somewhere in those ancient lights, we see ourselves. James Webb isn't the end of exploration. It's a baton, handed to the next dreamers, to the next questions, to you. So look up, not just at the stars, but at the story we're writing among them. Because space is no longer just out there. It's ours. And this is only the beginning. Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH. Until next time.